At the heart of everything in Azure is networking. You have to be able to get to it, so networking from on-premises or outside of Azure, because you can't be working inside of the network itself. So an understanding about networking in general, public and private IP addresses, is a core skill that you have to be able to administer it. We're going to start off a whole series of components where we're going to take a look at the various pieces of networking that you need to have. So my name is Bob Tickleman. I'm excited to be your guide for this module on virtual networking, and specifically public-private IP addresses and a thing called a VNet. Let's get into this. We're going to take a look at some of the fundamentals of networking, specifically IP address and specifically IPv4 address spaces that you're working with, both public and private. We'll take a look at creating a thing called a VNet and then the subnets within them. When you take a look at networking, the whole concept is that it has to be consistent wherever you want to use it. Imagine if the phone system that we had here in North America was different than it was in Europe. We would need some kind of interface to provide that communication. Internet networking is based around these principles that we have been using on premises for decades, and the same premises hold true inside of Azure. The only real difference is it's software-defined networking, and you're not really working at the physical level like you're probably used to of plugging in cables and network cards. This is all done through virtual networking components that we need to get in and work with. So when you take a look at a VNet, which is the term that some of you might have just called a subnet in the past, we're going to take a look at all these different pieces and where they fit together. We'll take a look at how they get assembled, how you configure them, and then have them communicate with each other. As I've done in the past, I want to go to a whiteboard just to provide some of this understanding. So what you're seeing here is a building, something that you might be familiar with and around the networking that you've done. Now I'm going to take this same concept and hopefully you'll see how we translate that to the language of Azure. I'm using a private IP address range, specifically the 10.2 with the CIDR notation of /16. So that splits the network address from the local host components. Again, nothing different than you're working with. Inside of Azure, we're going to call this a VNet. As the base unit of networking that you create. Inside of a VNet, you can create one or more subnets. I'll call this subnet 1, 2, and 3. I could call it front end, business tier, middle tier for that three-tiered architecture that we've referred to in other portions of these recordings. Now what I could do is define the subnet from the address space of the VNet. So you'll see these terms come up when I do the demonstration. This is the address space of the VNet, and then for the subnet it has to have a name. And then it has to have the address space. And it could be some or all of the portion of the VNet's address space. And here, I'm going to make it 10.2.1.0/24. Subnet number 2 as its name, I'm going to have its address space as 10.2.2.0/24. And subnet number 3 is 10.2.3.0/24. So this one piece we're going to build in the portal as a software-defined VNet with 3 subnets, each having an address space that is a sub-portion. Now we're going to take a look at other recordings where we get into specific networks like gateway networks and bastion networks, firewall networks, that you might want to use something other than the full octet of an address space to be able to use, and we'll take a look at some of the features in there. Now, when we go back to the books, I also want to point out that while we're giving it the full final octet in here, which would typically give you the address spaces of 0, 3, 4, 5, 6, 7, 8, which is equal to 0, or 255, which is equal to 1, 2, 3, 4. Now, TCP/IP says that the first and last address, in this case the first and last address, are not available to you. So you don't have all 256, you actually have 254 addresses available to you. Inside of the software-defined networking of Azure, we take the first 3. Now, some people say the first 5, and what they're referring to is when they say 5, TCP/IP takes 2, and Microsoft takes the next 3. In this case, it's going to take 1, 2, and 3. Now, I want to be very careful how I say this. I'm not taking the address space 1, 2, and 3. I'm taking the first available, the second, and the third available. Because if I'm not using the entire subnet, so let's say, for example, if you're familiar with TCP/IP, if I make this 25, in fact, the address spaces run from 0 to 126 and 127 to 255. So I'm going to take the first 3, which is 1, 2, and 3, and here you're going to take 128, 129, and 130. So depending on the address space that you're working with, it's not 1, 2, and 3. It's the first 3 available in whatever the address space that you're working with. So if you're working with maybe 0 to 63, 64 to 128 that you're dealing with, again, it's going to be 65, 66, 67. So you got to think about this. Now, what Microsoft uses these first 3 for is the first one is going to become a thing called the default gateway. So in this subnet, 0 is gone, 1 is going to be decided for the default gateway, and then 2 and 3 is going to be used for DNS in the namespace for that network subnet. And inside of the network itself, it uses DHCP, you don't have to configure it, to allocate all of the address spaces that are going to be in here. So if I were to put a VM into here, the first address is going to be, in this case, 10.2.1.4. Now, even if you statically map these, we recommend that what you do is do some of this through the static mapping at the software-defined phase, and don't do it at the virtual machine. You'll see this come up on one of the slides, is you do not manage the IP addresses inside of the virtual machine. You do it at the software-defined piece that allocates that to the virtual machine itself, because you can potentially run into some issues. So this is the concept. You're familiar with it on the on-premises world, and the same thing is going to happen inside of Azure. By default, while we've got a default gateway for each of these subnets, so this one is going to be 10.2.2.1, this one's going to be 10.2.1.1, 10.2.3.1. So if this virtual machine down here has an IP address of 10.2.3.4, and it wants to talk to this virtual machine up here at 10.2.1.52, it would then do everything that you're familiar with TCP/IP. It would check its network address at 10.2.3, check against the address of this one up here at 10.2.1. It would forward that request to the default gateway, who then has, and then you'll hear the terms called a UDR or an SDR, system-defined route or a user-defined route. By default, eye-winking moment for those of you who are interested in exam, by default, all of the subnets inside of a VNet automatically talk to each other. So there is a route table that has system-defined routes that says to get to the 2, you go there. To get to the 1, you get there. This one can get to the 1 and the 2. And the 1 can come here and there. So all the subnets in a VNet by default talk to each other. So they're all going to be able to communicate. And so it would just behave like you would in a regular network. For this virtual machine, it would then have to go to the default gateway. Now, you don't have to build these router and the route tables, all that information. It automatically happens when you build the VNet. And you'll see this when we get in and work with this. And I'll do a stage set of live demos where I'm actually going to build these VNets, tie them together, ping devices on either one. But that concept is what you've known networking to be everywhere, public and private IP addresses. And if I need to communicate to some other location, so if you wanted to go out through the internet, you would have to have a gateway, or a public IP address that you could allocate to this resource so that people who are at home that wanted to access that resource could access it in the public IP address to get this. So all of these concepts, exactly the same that you've thought of networking. So let's go back to the books. We'll take a look at the learning, and then we'll go take a look at a demo of that environment. So taking that information back to the content. Everything is exactly as we've talked about and everything you've known before. You're seeing our virtual network here as the IP address that you're going to assign to the VNet itself. Now you could use some or all of that address space for the one or more subnets that you're going to build inside of it. And so it can consist of the entire VNet, or it can have specific numbers that you're working with that are subsets of it. I use that for my going from a /16 down to a /8. We saw that inside of it, individual addresses are going to be assigned information through the software-defined features and the automatic DHCP that's built in. Now, where you come up with that number 4 is, remember that as with every TCP/IP, the first and last address in the address space are taken away. Microsoft is going to take the first 3 available, so in our case of a full address space, we're going to take 1, 2, and 3 for the gateway address and the 2 DNS servers that we have for that subnet. And so the first available address is 4 in this case, and subsequent ones will be 5. We have that CEDAR notation you can use with /16, or you could then use the old subnet mask of 255, 255 if you wanted to take a look at. So just some networking fundamentals. The big difference is what you might have called my address space, or what you might have even called a subnet, we're calling a VNet, and then your sub addresses or the custom subnetting you might have done, we're calling those subnets. And the other difference is we've got some default numbers in addition to the required from TCP/IP that Microsoft is taking away for software-defined networking. This is backing up what we just talked about. Not all addresses are going to be available. That first and last one taken away for TCP/IP. And here you're saying it says the first 4 and the last IP address. It's kind of giving you a different name for what I've said. I've heard it said different ways. I like to say it the technical way. TCP/IP is taking the first and last. That's nothing different. The thing that is different is we're not taking 4. Microsoft is taking 3 of these for a very specific function. So the multicast and the broadcast and the loopback, those ones, the first and last, those are taken. And what we then have is the first 3 that are going to be taken for Microsoft. And so when you see this, and you used to have to be able to figure out how many addresses and what the first address space, the nice thing about the graphical interface is it will tell you. So as soon as you take a number like this, 10.0.04/16, it knows it's splitting there. It knows that you've got 65,536 addresses, and it will then tell you what the address space is going to be. Now, if you go to 24, you're going to get 256, but remember, TCP/IP is taking 2 plus the 3 from Microsoft, so you're actually going to get 251 as the available address spaces inside of that subnet. Now, when you're planning for your addresses, standard rules apply. If you have 2 networks that are talking to each other directly, they cannot have overlapping IP addresses. The same thing is true here. I'll show an example when I get to the live demo. The same thing happens when you create a VNet inside of an Azure subscription. It will then pick the next available space based around other address spaces that have already been used against that subscription. It doesn't mean that you can't override that. It's just that you have to be aware that by default, it's going to try and pick another available address within the address space, whether it be 10, 172.16, or 192.168. So those 3 private IP addresses, it will then monitor within its own allocation that you could then override if you want. But just know that, like TCP/IP, if those 2 subnets are going to try and talk to each other directly, you're going to have a potential problem of overlapping IP addresses. So, ensure that your address spaces don't overlap. Use a small range of virtual networks as possible instead of having big large ones, because that's going to make the number of available addresses. You still want to be economical within your IP allocation, because even though you could reuse them for different solutions, you might have a growth inside of your own solution. And if you've already crippled it by having very big networks where you're wasting a lot of IP addresses, it makes the growth of that environment very limited. So pick the appropriate number. You can always expand it after the fact. Now this comes into that point that I was mentioning. Never manage the IP addresses from within the virtual machine. You still remember that even though you put an IP address in at the operating system level, that's the IP address it works with, but the software-defined network managed by Microsoft that manages all of the actual physical communications, if those two IP addresses conflict, you're going to potentially have a communications issue. So all of the standard ones, but I just want to again pull out that one here as a specific note that you may want to pay attention to. Hopefully you're familiar with the difference between public and private IP addresses. If you're only communicating internally, you can then use the private IP addresses, and they fall in that range of 10.0.0.0/8. You've got your 172.16.0.0/12 and your 192.168.0.0/16. Those are the private IP address spaces that you're working with. They're still available to you. There's nothing different. Microsoft, and this changed a little while ago, if you want to use public IP addresses, you must use the public IP addresses that are given to you through the Azure region in which you're deploying the resources. Microsoft has pools of public IP addresses. They're available for you to pull items out of the pool, and you can either do it dynamically, where you're only going to pay for what you use when you use it, or you can have statically mapped IP addresses that you pull out of the pool, and whether you're using them or not, they're going to be allocated for you and you alone, but you'll be paying for them the entire time that you have it as a private IP address. Now, this rule changed a little while ago. You can now bring your own public IP addresses to Azure if you have a full Class C license. So if you could bring that entire Class C license, you could then register it with Azure and use it across a region deployment that you're working with. You must provide proof of ownership of that Class C license to be able to use it across Azure. So that's something that might be a little bit different than the content you're taking a look at. They're giving you some examples of where you could use public and private. Now, I would strongly recommend that you use the private IP addresses inside of Azure for private networking. You typically want to only use public IP addresses in that public-private ingress-egress. Because there is extra cost for private IP addresses, and they can potentially be restrictive, you might want to keep public IP addresses only for that public-private ingress-egress. Typically when you're putting maybe a firewall or a gateway available to the public to access is where you're going to want to use those. And you see them Azure firewalls, app gateways, and we'll be taking a look at these different network resources through the series of recordings that we have on this topic. So I'm going to go over and do that demonstration of the creation of a VNet. We're going to show you the assignment of an IP address range. You're going to see those numbers come out, and we'll take a look at what we can work with. I'm back in the portal. I'm going to create a resource, and I want to create a virtual network. You'll see that there's very little I need to configure. I'm going to have my subscription. I'm going to pick an existing resource group. I've already got one I could use. I could pick another one if I wanted. And I want to create a VNet name. I create this as VNet02 and the region to deploy it. VNets are a regionally based resource. I'll give that as kind of an eye-winking moment for an exam perspective. If you want, they can communicate to other VNets and other networks, but a VNet cannot span regions. So if you want to work with security, there's a couple of features we really didn't talk about. By default, the communication within the VNet is secure. You and you alone can see that information, but it's not encrypted. In other recordings, we'll talk about encrypted traffic, but I want to touch just briefly on Azure Bastion and Azure Firewall. These also will be covered in other recordings, but these are very specific subnets that need to be created in possibly a hub and spoke topology. I'll come back to that later. This is what we were talking about when we were looking at the slides and the whiteboard. you want to define the VNet address space. And it's going to come up by default with the address space that's first available in this subscription, in this resource. So if I had already created some, you might see numbers deprecated from this list, but it's giving me the first available. I could delete the address space, use a different one if I wanted. I could edit this one. I'm going to call this front end. I then give it the subnet that I'm looking for, so I'm going to take it down from the /16 to a /24. And you can see that it gives me all the options for the different CEDAR notations that I could go down to 25, 26, and you'll see that you get smaller and smaller subnets that you're working with. I'll leave it at /24. I can have IPv6 addresses if I wanted to. Again, we're going to take a look at security, routing groups, routing tables that you're working with. I'm not going to deal with this. I'm just going to create a very simple one. I'm actually going to create 2 additional ones. I'm going to create a business tier in my 3-tiered network. And you can see it automatically picked up the next available address space at 10.0.1. And I'll add another one, and it should go to 10.0.2. And I'll call this backend. Review and create. This happens relatively quickly. I'll just go in and take a look at it, and then we're going to be done with this demonstration. That was live. It didn't take very long. And so what I now get into is what is the address space. Now it's quite interesting. Remember I talked about it doesn't stop you. The recommendation is that you do not overlap the address spaces, but it let me create it so I can still use it, but it's giving me a warning here. So we'll see that I've already overlapped this with another VNet. And as long as they're not talking together, it's not going to stop this from happening, just that it's giving me a warning that I'm not going to be able to use that. Or I could get in and change it if I needed to. You can take a look at the connected devices, if there were any, and we'll be doing this over a series of recording as I start adding resources to these VNets and the subnets. You'll come back and take a look at this and you'll start to see the connected devices. And here we have our 3 subnets, and there's that number 251. Remember that even though I have the full octet, 0 to 256, I don't have all the addresses because those 5, the 2 from TCP/IP and the 3 from Microsoft, the first available address is 4, and I have 251 total. And you'll see that number go down as I start to allocate resources. Okay, so that's VNetting. Let's go back and close up this module. So as a starting point of virtual networking in Azure, we needed to understand the basics. And hopefully you saw that they're not much different than what you've already known. TCP/IP is TCP/IP on premises, in the cloud, in the public domain. It just works exactly the same way. We've learned a few terms possibly. We still have private IP addresses, and those 3 IPv4 addresses are available for you. I was using the 10 dot. And then we have this thing called a VNet. So you create a VNet, which is an address space, using the CEDAR notation to identify what is the network address versus the local host. And then you break it up into 1 or more subnets. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.